So welcome all to our talk about joining these Cephalapods, adding SMB support to Ceph. My name is Günther Deschner. I have with me here my colleague John Mulligan.
Hello.
We both work for IBM and are part of the Ceph team. So maybe you got aware of that in the news. There was a big storage organization within Red Hat that got moved to IBM. So we kind of suddenly became IBMers. So it's a very interesting experience so far. We're also both part of the open source community. We work on the Samba project both. And you pressed the wrong button, but that's not an issue. Nope.
Not working.
Sorry. Okay, there we go. Yeah, so for myself, I've been with the Samba team for a very long time. I tried to figure out the exact date when I had my first Samba team contributions. I think it was something in 2005, but it could also be 1 or 2 years off, so almost since 20 years. And since then, I was really looking into all aspects of Samba, beginning with working on the identity components, on Winbind, Active Directory integration, but then also later on some more of the SMB3 feature set. I was working with Red Hat for a long time before that, and we kind of designed a storage product based on Gluster, another open source clustered file system, to bring the SMB support to that. And while doing that, also worked on features like multi-channel and witness a little bit. So I was just really helping the efforts of the overall team. And yeah, so since some time now, I work as a manager, so I have a whole team of engineers, and we look into integrating SMB into Ceph at the moment. Yeah. So, John, you want to say something about you?
Yep. Hi, I'm John. I report to Gunther. I've been working in the storage industry for a few years, usually on administration and management. I recently joined the Samba team as of a couple months ago, so thank you all.
So what we are talking today, that's really kind of a hidden disclaimer. So we're not talking about any IBM products or something like that. So we're also not kind of part of any product management. We are really kind of the engineering organization, and we want to talk today about our work with the open source components, what we did in Samba and within Ceph in order to help the integration go forward. So as a quick overview of what we are planning to talk about. First, really just very quickly a kind of introduction of what Ceph really is and what the primary art in that field actually is. So we're not really starting out of the green, but there has been some other development done in that direction already. And then we want to have a deep inspection on really what we did, and which I think to great success in really improving the orchestration support to really make it very easy to set up Samba clusters on top of a Ceph infrastructure to make it really kind of equivalent to the already existing work of integrating NFS using NFS Ganesha on Ceph. We're talking about that. We even have prepared a nice demonstration where you can actually see how the user interface really works, how you can really set up and deploy a Samba cluster on top of CephFS. So that's also part. We did it pre-recorded, so we didn't went down the adventure road to really do it all live. And then we want to, of course, talk a little bit about the ongoing improvements and all the future work or roadmap items. And yeah, conclude then with question and answers. So real quick, I don't want to go into very deep detail what Ceph really is. So it's an open source storage infrastructure that really has a comprehensive approach to cover a file, block, and object store. It is well established in the industry, so there are many big and huge users of that already. It's a scalable solution that really can cover very large infrastructure and storage needs. It consists of a protocol. It consists of a whole list of protocols. I put them all here on the screen. Rados, which is really kind of the core protocol that holds the object-based storage layer, where all the other components are building upon. There is the RBD, the block component of Ceph. And then there is CephFS, which is one of the oldest components of Ceph, the one that we really are focusing most on. For that reason, it's also kind of put into bold letters here. It really provides a POSIX-like interface for the whole storage infrastructure. There's also RGW, the Ceph HTTP object protocol, we don't touch on that at all. And then on the server side, Ceph consists of a couple of daemons. There's the Mon daemon, the OSDs, which then really kind of do provide the storage nodes, the MDS, and then the manager daemon, which is the area of work that John, my colleague, has been mostly spending his work on to kind of improve the way how you can centrally manage and orchestrate services on top of Ceph. So if you want to know more about Ceph, there's a whole bunch of very good marketing material out there, very good slide decks. So yeah, I don't want to bother with that so much right now. So if you then think about Ceph and SMB, there is already some experience out there in the field. People have been setting it up. There has been some companies who put a lot of effort into improving the compatibility and the integration. Notably, SUSE has spent a lot of time in providing very deep integration already. So there are many building blocks out there. But what we found is that there's really a lack of active development, a lack of a deep integration. It's not really part of a cohesive platform. So it's really many building blocks out there, which are partly well maintained. Some of them are not maintained at all, which we found out. So we, of course, took the challenge to really improve on all these fronts. And yeah, we also were aware that there were some really quite visible limitations when it comes to performance in particular around there. We are very aware of them. We have a couple of ideas how to overcome these limitations. We will also cover this on some of the next slides. Right, and with this, I hand it over to my colleague, John.
Hello, thank you, Gunther. I appreciate the introduction. So, as the slide says, and we've mentioned already, Ceph already has some integration with NFS. What we want to do is provide a roughly equivalent platform for SMB. One of the things that we gain from this is having a standard deployment method. We get to be able to reuse various components in Ceph's framework. And administrators who are already familiar with Ceph will also be able to use SMB in a similar workflow. As Gunther already touched on, we're building on top of shoulders of giants. We are reusing a number of various open source components. And in addition, we are building a small ecosystem around Samba and containers. Within Samba itself, we're able to reuse Samba's VFS module for Ceph, its VFS module for snapshots, as well as some Rados integration around Samba's CTDP component. Back in 2020, one of my colleagues, Michael Adam, started the Samba Containers project. This is intended to wrap Samba in a standard container platform, the OCI container, and provide standard workflows around it. This is then integrated with a library called Samba CC. It's a Python tool that integrates Samba and makes it easier to run within a containerized environment. In addition to these deliverables, we have Samba Build, which allows us to build Samba packages from source, as well as a testing platform also maintained by members of our team. Finally, we had originally been working on a Samba container, Samba Kubernetes operator. This operator is not used within the Ceph platform, but the work that we did while working on it was a huge learning, and we were able to reuse a lot of that knowledge when we started integrating with Ceph. So, one of the main integration points was a tool called Ceph ADM. Ceph ADM is Ceph's own native container orchestration platform. Ceph ADM has very few requirements. It basically runs on a Linux host with systemd, Podman or Docker, and Python. The Ceph ADM system is divided into two halves. One runs within the manager server component, and another half runs on every node in the cluster, and this is colloquially known as the Ceph ADM binary. When I contrast and compare Ceph ADM to what we've previously done in Kubernetes, we have a lot of fewer constraints on what we can do, but we also had to build a whole lot of building blocks on our own. In particular, networking is both much more flexible, but fewer good guidelines are provided. So, how did we add Samba integration to Ceph ADM? Ceph ADM was able to deploy simple containers, but we needed to enhance the container deployment methods. We added init containers and sidecar containers, which are concepts that have smaller helper containers surrounding the primary deliverable container. Ceph ADM has a concept of services, and these are the things that it deploys. We were able to add a Ceph ADM service so that Ceph ADM can make the stuff go. We have a various number of combinations of features, and each of these is going to deploy a different set of containers. Active Directory will deploy sidecars for Winbind, for example. We have containers for monitoring metrics. We have synchronization with Ceph. And in particular, CTDB required a number of additional containers. Finally, we added a whole new Ceph Manager module. This is roughly equivalent to the existing NFS Manager module. It kind of is the interface that admins will be using to interact with the system, and it kind of glues everything together. There are two suites of commands that it provides: an imperative command set, wherein one says things like container create, container delete. I said container. I meant cluster. Or you can use the declarative approach, wherein you supply a description of what you want the cluster to look like, and you can provide one of 4 different kinds of resources: the cluster, the share, users and groups configuration, and join authentication. Finally, this is the piece of the system that understands the various components and organizes them all. So as Gunther mentioned, we've prepared a short demo. It's a pre-recorded demo because no one wants me to deal with bad conference internet and/or my many typos. So I'll start that in a moment, but if you'd like to look at some of the things that I'm about to show in more detail, you can follow the link or the QR code. It should bring you to a GitHub discussion. And before I jump in, I'll mention that this is a 5-node Ceph cluster, all running on virtual machines. We've already supplied an Active Directory DC based on Samba DC. We have 2 clients, a Windows and a Linux client, and all of this code is already available in Ceph's main branch. So if you're feeling adventurous, you could follow along at home. All right, starting the demo. So this starts off right after I've installed the cluster. One of the things to note is this module is experimental and therefore not enabled by default, so we're going to turn it on. Next, we're going to set up the Ceph volumes that we need. For what it's worth, Ceph does use some interesting terminology, so feel free to look at the Ceph-FS documentation for a little bit more details about how the Ceph file system is organized. So we've created a file system. We've also created a subvolume group. Now we're going to prepare 4 subvolumes for the rest of the demo. 2 of the subvolumes will be assigned to one of our SMB clusters, and 2 other subvolumes will be assigned to our second cluster. Each subvolume will be a member of the existing subvolume group that we've just created. This is the part where my typing is slower than my talking. All right, so we've created the 4 subvolumes, and now we'll move on to preparing the nodes. Node preparation is not strictly required for this demo, but it does help me predict exactly where the various server components will land. So we're going to label the first node in the cluster first. They're all pretty arbitrary. And then we're going to label 3 additional nodes in the cluster with this CS2 label. We'll just double check that with a host ls. A quick overview of our nodes and labels in the cluster. Finally, we can start building up our SMB cluster. We're going to use the imperative command set for this part of the demo. And as you can see, there are no existing clusters here. For what it's worth, cluster in this context is a logical unit. Not all SMB clusters are actually clustered in the CTDB sense. We'll start creating a cluster here. And as you can see, we've supplied a name of starter. The type is user, meaning that we have our own defined users and groups. We're not using Active Directory. And we're going to supply a couple of users and their passwords on the command line. And this is an edited demo because you should have seen how many typos I made in real life. So finally, we're going to supply a placement. A placement is a Ceph ADM concept that controls exactly where the services will run within the Ceph cluster. That count of 1 means that this will not use CTDP. So now that we've defined the cluster, we can start defining shares that belong to this cluster. And I have to move because I don't know what I'm doing. Yes, so the important thing here to note is that the share is linked to a subvolume. There are additional parameters that I'm not supplying in order to make the demo quick. Second share here is going to use a share name parameter. This allows us to use more characters that are valid in a proper SMB share name than the Ceph share ID. And for what it's worth, you can specify paths inside the subvolume, but Ceph doesn't have a capability of creating them automatically, so if we were to come back later, we could create new shares in subdirectories. So now that we've defined our 2 shares, we can use the SMB show subcommand to list the contents of the configuration database. In addition, we can limit what resources that we're showing by specifying the resource name. And we can also include the resource type and ID. Finally, we're going to, it's jumping ahead of me. Anyway, long story short, we created some shares and we used the Ceph orchestration command to show that the service was running. Now I've jumped over to the Linux client, and I'm going to use Samba's SMB command to demonstrate that the cluster is live. So we've connected to the first share. We'll do a quick test to show that we can write to said share. And then we will switch over to the second user. So that was successful, and we'll check the second share quickly. Don't worry, we're not going to just stay on the command line the whole time in this demo. So we've demonstrated we have one SMB cluster running on our overall Ceph cluster. So now we're going to create a second SMB cluster within our Ceph cluster. This time we're going to use the declarative method. I've already copied some YAML to the system. I'm not going to go over every single line. That would take forever. Just note that this cluster is configured for both Active Directory and CTDB. It will run on all the nodes that we've labeled as CS2. We've defined a set of shares as well as the authentication information needed to join the Active Directory. We can submit this resource set to Ceph using the SMB apply command. Now that the system has been loaded up with our new resources, we'll run the orch-ls command and see that Ceph ADM is aware of the new service, but is not running it yet. We need to wait until we have 3 out of 3. In the meantime, I'll use the Ceph SMB show command again to show that the new resources are indeed part of our configuration. As before, you can limit what you see by specifying additional information on the command line. Now that we've given it a moment, we'll use Ceph orch-ls one more time. Oh, it's still taking a moment to start up. Any second now it should be ready. Come on, past me, you can do it. Ceph ADM has started all of our clustered SMB services. So we'll take this opportunity to switch over to our Windows client, already joined to Active Directory. We'll log in and we'll start using Windows Explorer to take a look at the shares. We'll be using one of the public IP addresses we defined in the YAML. As you can see, both shares have been automatically recognized by Windows. We'll do a quick test here, just to make sure that we can do a write. And as you can see, we were able to write the file, but wait a minute, we haven't forgotten about our original cluster. So we'll specify the IP address of the first node. And as noted before, this is not joined to Active Directory, so we should be prompted for a new login. We'll put that information in, and we should see the file that we specified earlier. So that's basically the end of the demo. Although I do have one deleting scene where I remove a cluster, just to once more demonstrate that our SMB clusters are indeed independent of each other and that you can have multiple running on the same Ceph instance. You can delete, we do require that the shares are deleted before the cluster, so we'll manually remove our shares. And then we will show that the cluster is still running because we haven't deleted it yet. We'll remove the cluster. And I will also note that you can also remove the clusters using the declarative method in addition to the imperative. Finally, you can see that the orchestrator has removed our SMB cluster but left the AD cluster alone. And that reaches the end of our demo. I shall return us to the slide deck and hand things back to Gunther.
Yeah, thank you, John. So I think that's really quite impressive to see how easily you actually can bring up cluster, or you can bring up 10 clusters or 50 or something like this, just on one storage infrastructure with just a bunch of simple commands or even just some pre-prepared YAML files. So I guess there will be many interesting use cases. And you also see that really majority of the efforts that we are spending on this work right now has been in this orchestration area to really first find ways to make this thing really usable, to easy to set up and really useful from the early beginning. Of course, there are many specific technical details that we now, in the next step, need to take a closer look at. So first of all, and I had a couple of discussions about this already here at the conference with other people, there are different approaches to really just access the Ceph storage, right? So there is a kernel Cephfs module a long time around already. There's also a Fuse module available, which is not as well maintained, I think, but at least the kernel Cephfs module is very prominently used also by many users who basically set up Ceph and SMB right now. So they most of the time use the kernel module. But there's also this user space library, which is kind of providing the same POSIX-like interfaces, and that the VFS Ceph module, which is present in Samba, has been consuming and using. So we took a close look at this module for a couple of reasons. First of all, there have been complaints about the many changes that went into Samba in order to rework the internal VFS interface to completely move to handle-based operations. Were not all completely correctly implemented in the VFS module. So we definitely wanted to take ownership of that module and really fix all these things. So we looked at all the newly added add variants within libcepfs to really use them all, so to be more accurate and more correct in the overall behavior and to finally resolve all these outstanding bugs. So this was one of the first things that we did. And then we also got aware that due to this development that the NFS Ganesha was doing with regard to Cephfs, they added a lot of improvements to the library. In particular, they added a whole low-level based API within that library, so that allows to really directly communicate with inodes to save a lot of lookup operations and things like that. Also, some of the NFS delegation work is exposed to some extent using that interface. So there are many interesting, I wouldn't say low-hanging fruits, but there's many infrastructure available right now in libcepfs that we want to leverage in one of the next steps. And for that reason, we are also mostly focusing on taking the approach of using the VFS Ceph module. We kind of reworked it completely with a different name because it was kind of a rewrite of the entire module, basically. So we really spend a lot of time right now on this aspect in refreshing the VFS Ceph module, and also really have a very specific attention to testing this, right? Because as you know, in the Samba testing infrastructure, which is really great, there's this big limitation that it's not kind of capable of testing clustered file systems such as Luster, Gluster, you name it, Ceph, of course, as well. So there have been talks and other conferences where we give a presentation about this whole testing infrastructure, which is hugely based on the Samba testing utilities, to build up our own testing specifically for testing out these modules that use clustered file systems. Then, of course, another big area of work that we're currently spending a lot of time is the whole performance aspect. As you know, with Samba, you have this process model where you have a main SMBD daemon, which is then forking processes for each client. And each client is loading basically the VFS module independently. And if you think of VFS modules that just have a very, very slim interface, they don't have a lot of dependencies. This is all not of a big concern, but in our case, each SMBD process really then becomes an independent VFS client, which is really loading its own copy of the libcepfs library at the cost of really a very expensive memory footprint, first of all, and also latency and other side effects. So this is, of course, a serious limitation for scalability, because you can easily, with a few amount of clients, consume all the existing resources on your server. So this is something we definitely want to overcome. There have been a couple of discussions how we could do this. One of our current approaches is to basically within that libcepfs library create some proxy infrastructure that allows to basically have, again, a very shim layer, a very thin library that will then communicate with one Cephfs client instance. So that's currently what we are pursuing so far to some good results. There is a prototype of this proxy infrastructure available as a pull request in Ceph. There's a good discussion about this going on. And it already resolves a couple of problems right now. In particular, also the switch to this low-level API allowed us finally to complete some of the outstanding limitations that this module had earlier, which was no support for supplementary group memberships. Because this low-level API basically passes down the user token to the lower levels of libcepfs that makes it possible to properly communicate the full group and token information to Ceph and then make the right authorization decisions. So this proxy work and this new VFS module are now kind of out there in the public for further inspection. And yeah, we also added a very simple switch in the current VFS module to basically turn on or off this proxy so that you're kind of not enforced to kind of follow our current experimental approach with that proxy. So we can always just revert back to the old behavior of just linking against that other library. Yeah, then of course there is a big problem with case sensitivity requirements. There is a big amount of round trips really spent in these expensive case forwarding operations for many SMB operations that Cephfs is currently not dealing with at all very well. In Samba, there has been one API provided, the getRealFileName call, that basically allows you to just ask for a file name, and the file system then can give you back in an operation the appropriate file name in the proper case that is really stored on disk, so that you can in future save these expensive round trips. That is something we do not implement, but Ceph itself is most likely providing very soon an ability to completely behave case insensitive. So there's been a discussion started and also well discussed in many of the Ceph monthly developer meetings. So all that is in the public. If you look for these things, you will find them. So we expect that one of the future versions of Ceph will really have an ability to basically turn the file system to case insensitive mode by just setting an extended attribute in, I think, at the top sub-volume level or something like this. So I don't know all the details, but so this is a design that we don't need to further do a lot of things about from Samba. So once that really gets available, we can immediately use that. And we expect then, at least from our measurements, a 30% improvement in performance, which sounds a lot right now, but so there are many areas that we need to further improve and looking for performance boosts. Then, of course, we are very well aware of some other limitations that we have with clustering in general. So there have been discussions in the past about limitations that CTDB itself has when it comes to sizing, when it comes to database sizes, and to some scenarios where you could have a record lock contention, which can turn out to be very expensive and really kind of a blocking thing in some scenarios. So these are definitely things that we also want to spend more time and energy on. There is also a growing interest in really supporting protocols in parallel, like NFS and SMB. So there's been a tremendous amount of good discussions here at the conference as well that we also will very carefully process and see how we will pursue with these things. The other thing is also the NFS Ganesha support for Ceph currently uses also this libcepfs interface, and libcepfs is, of course, then also for us a very good utility and a vehicle to bring in some of these multi-protocol aspects to APIs so that we can more easily attach multiple different protocol heads to these things. Much easier than probably having to implement all these things in a kernel and then doing some weird IOCL operations in order to get all these things rolling. So that's definitely one of the things that we will look also more in the future. Then we would also like to leverage that work that Stefan Metzmacher did for a transparent failover with the witness protocol. Again, we are also hoping to first overcome this known limitation with the dependency to persistent file handles, where we either have this overloaded event log on the Windows clients, or we just wait until Ralph finally gets his persistent file handles implementation ready. Then we will, of course, be very happy early adopters of that. Yeah, then we have also some other pieces here on the list. Yeah, we are looking, of course, because there's a lot of customer requests as well, to provide integration into Entra ID, and there has been this tremendous research work with now also a complete implementation, if I'm not mistaken, done by David Mulder from SUSE. So there's a lot of really exciting work in the Samba community, the Samba open source world, available that we will soon, one by one, really start adding to our solution, because there's really a lot of interest from our customers. And yeah, there are also another set of low-hanging fruits for the Samba VFS module, because the NFS Ganesha people are also working on features that are very, very similar to the ones that we are looking, so we can pick up very soon another asynchronous I/O framework that is provided by libsafs, and also a zero copy of a set of function calls. So we will look into these things as well. Yeah, and this brings us to the end of our presentation already. So I hope you enjoyed it. There were no questions so far, but maybe you have some now. We're happy to take. Yep, Volker.
I know this you can't proper. I know there is probably not really anything existing, but this whole topic to get rid of CTB to make it more scalable. Is there any work somewhere inside IBM to say, okay, we have a fast DLM that we could utilize, or Ceph probably doesn't provide anything? I mean, and there has been this liberator's wrap backend, which is just too slow because you don't want. I mean, you could put secrets CDB there, but not blocking TDB.
Yeah, so the question was whether within IBM and with the projects that we work with, whether there has been some considerations to overcome some of the CTDB limitations by replacing it completely with some of the other databases, or in general, just if there is some infrastructure available. So right now, no. So we definitely also want to pick up that work that Ralph has been doing to kind of introduce it kind of generic backend, first of all, in order to repeat these testings that he did in order to see if this liberator's performance really was as bad as it was in these past tests. So we don't have a direct infrastructure available right now that we can just easily plug and replace. But there are also some other interesting ideas that maybe John wants to comment on for leveraging Rados. Yeah. Sure.
I still went the path to put SMB knowledge into their file system, like 20 years ago. Has that been discussed with Ceph to essentially put the full share modes, sleeves, and so on into Ceph?
Yeah, that's another interesting question. The question was whether the file systems actually has thought about implementing some of the SMB semantic requirements directly in the file system, like share modes.
Or NFS delegations.
Or NFS delegations, exactly. So yes, this CephFS client does a couple of things for NFS Ganesha specifically, like delegations. And if you look at things like the Ceph client capabilities, for example, that is kind of a concept of leasing actually already present in Ceph that currently only NFS Ganesha leverages. So it has been created on their demand, as far as I can tell. And that's one of the next things that we definitely need to look at to see if we can kind of translate that semantic-wise and expand it so that it would also be suitable for our needs. So this is definitely one of the next points of discussions, I'd say. Another question?
Did it cover all of the needed AT calls? Because there were quite a few that were missing.
Yeah, so the question was whether we can actually replace all the add variants which are available as Linux system calls with libcepfs calls. So I do think that we have a replacement for all of them right now. So there has been some even added on our demand. There has been really some added to the API, to libcepfs API, but never really picked up by Samba because no one was really aware of these changes. So that's one of the things, yeah. John?
Yeah, for what it's worth, there are a few API calls that were in libcepfs for years, and there are still code comments in the VFS module that Ceph doesn't have this. So there has definitely been a desync between what was going on in the Samba space and what was going on in the Ceph space.
Okay. Any other questions?
Sounds good.
Okay,
Right.
then thank you very much.
Thank you.